So our next lesson is going to be over area of a sector. The formula that we'll be using is very similar to finding arc length. The only thing that will be different is our pi r squared, because we're finding area of a sector. So the central angle, the measure of the arc, depending on how you read it in the formula, it's the same thing here. That right there is the same as, our arc degree out there, goes with our central angle. Find the degree, put it over 360, and multiply by pi r squared. So we'll have to also have our radius for our formula. So our first example, we'll be finding the exact area of the shaded region. In the past, you have worked with finding area of circles by using pi r squared. Well, now we're trying to find the area of a portion of the circle. Okay, and so the portion is usually shaded, which we have here, that's blue. Okay, and we're going to be using the formula up top. Theta, that's our degree right there, that will be our 100 degrees. Put it all over 360 times pi r squared, so our r is 6 squared. And so it did say exact, so that means we need pi in our answer. So when we multiply across, we'll get 10 pi. So example 2 is a huge jump from example 1. Example 1 was just talking about the basics of using the formula and knowing what each part represents in the formula. If you look over here, we know the arc length at 7.85, okay? And we know our 4 is our radius. Well, if you look at the formula in the top right-hand corner, in order to find the sector area, we need to know what theta is. We know what the r is, but we don't know what theta is. So we have to find it. But we find it by using our arc length formula that we learned earlier this week. So we have 7.85. Set it equal to the arc length formula, which would be, in this case, x over 360. X is representing theta times 2 pi r. Okay, and so you would need to work backwards, solve for x. X represent our theta, so we should get 112.44 degrees. Okay, so now we're going to use our degree measure here and substitute it into our formula, because we already know what r is, to find our sector area. So we have 112.44 over 360 times pi 4 squared. So our area will equal, round to the nearest tenth, 15.7. So example 3, we need to find the area of the shaded segment of the circle. So that's our red portion here. We'll also need to know that what kind of triangle we see here. This triangle right here is an equilateral triangle. So you need to remember that all sides are equal, all angles are equal. So our first thing we're going to do is find the area of the whole sector, which is all of this. Okay, so that's just going back and using this formula in the top right-hand corner. So 60 over 360 times pi 10 squared. I'm going to round to the nearest 100 just for this case. So 52.36. Now we need to find the area of the triangle. Okay, so the area of the triangle, you need to remember that the formula is 1/2 base times height. Okay, so let's pull the triangle out. Okay, so we know it's an equilateral triangle, so 10, 10, 10. The height is right down the middle. Okay, we know the angle are all equal to be 60. Okay, you could do one or two things. You can use a trig function, or you can use Pythagorean theorem. I'm just going to use Pythagorean theorem. So just part of the base would be 5. The hypotenuse is 10. And our height is x. I'm using this to help me find the height here. So 5 squared plus b squared equals 10 squared. Okay, so when you solve for b, your x value for your height, you will get 8.66. Okay, so that's our height. So now we need to find the area of the triangle. So that's going to be 1/2 base 10, height is 8.6. Okay, so the area here will be 43.3. So now, after we find the area of the sector and the area of the triangle, what do you think we need to do to find the area of the shaded part? We'll have to subtract. We'll have to subtract the 52.36 from the 43.3 to find our area of our shaded portion. Round to the nearest tenth, so 9.1.